All right, ladies and gentlemen, welcome back here. So in the last video, we saw kind of a premise of the area between the curves problem. So now we're just going to kind of develop the common way of solving an area between the two curves problem. So what we want to do when we're doing area between two curves is we want to think about creating one integral that will solve the area between the two curves problem. And the way to do that, we have like a top function, so this f of x minus g of x. And we must assume that f of x is greater than or equal to g of x. So what some people do to help set up their integral, they look at their a to b, so that's our a, and that's b, so that's the x-coordinates of our endpoints of the area between the curves. I like to call these like pond problems, so this could be like the beginning of a pond and the end of a pond. And we do the top minus the bottom, and that is the main idea of this. So with that, we develop this sort of checklist of what I'm looking for each time. So first thing I'd like you to do is create an integral that features the top function subtracted by the bottom function. I'm also looking that you are considering the limits of integration. So on the easier ones, I will give you the limits of integration. On the harder ones, I will not give you the limit of integration. So we'll talk about how do we get those limits of integration. And then we evaluate that definite integral that will get you your exact area. So on this first one, it says find the area of a curve bounded by y equals to x squared plus 2. So that's pretty obviously your parabola. And y equals to negative x. And you're going to take the bound between x equals 0 and x equals 1. So you're going to look at everything between those curves. And I like to sketch out that area between those curves. So we're computing that area. So on the nice problems, I will give you a graph. So we're taking the integral of top minus bottom. And we're taking the integral from 0 to 1 of x squared plus 2 minus a negative x. And when we combine like terms, this gets transformed into a power rule integral. So the end result that we have here is that we are going to have 1/2 x squared, or what's 1/3 x cubed, plus 1/2 x squared plus 2x plus c. And we're going to evaluate it from 1 to 0. So when we plug in 0, that's pretty obviously going to be 0. But when we do 1, I'm going to put in a 1 each time. And if you like, changing to decimals, that's fine. It's not required. So we get 0.33 plus 0.5 plus 2. So that gives us about 2.88. And that gives us the exact area. So this is a pretty powerful tool because just by doing top minus bottom, we can create one integral that's at the level of a power rule integral and it has this exciting, geometric interpretation. We can compute areas of really curvy things that are, not even limited by, the x-axis, for instance. And we don't even have to worry about, Riemann sums or anything crazy like that. All right, so now we're going to operate on something a little bit at the next level. So this, I do not have a graph that I provide you. So on this one, my suggestion, just to help you think about what top and bottom would be, is to create a very rough graph. So y equals x, that's pretty easy to graph. So usually I give you one that's really easy to graph, like a y equals x or something like that. Then we go to 2 minus x squared. So that's a parabola that's downward facing. And doesn't need to be the exact points. You just need to know, what your top and your bottom are. So the top is the 2 minus x squared, and the bottom is the y equals x. But there's another problem. We don't know our limits of integration. So to find the limit of integration, we do 2 minus x squared, and we set that equal to x. And I'm just going to move the x squared to the other side. The x stays positive. And when we factor, we get x x plus 2 times x minus 1 equals to 0. So that results in x equals to negative 2 and x equals 1. So now we have a limit of integration. So we're going to integrate from negative 2 to 1. And we're going to subtract 2 minus x squared minus x and now we can take the antiderivative. So we get 2x minus a 1/3 x cubed minus a half x squared. And we're going to plug in a 1 and a negative 2. So I'll just tell you what you should get with your plugins. So if you're plugging in 1, you should get 2 minus a third minus a half. So that's about 1.16. Maybe 1.17 or so. And for the negative 2 plugin, you should get a negative 3 1/3. If you like fractional form better, that's fine too. So your answer is going to be 4.5 or 9/2. So this is really, kind of a full spectrum of problems. We're going to show you just a few more. Like sometimes it's even worthwhile to divide the problem into like 2 parts. And so we'll show you that on the next video.